Welcome to the Hang Up. Today, I will be taking us through the initial process of figuring out what we need to do to 3D print an airbox for an aeroplane. Nothing beats sitting down to finally get some productive work done, to find that your 3D printer head has been clogged up. It's the greatest feeling imaginable. So now, instead of getting productive work done, we sit here and we tinker. Alrighty, so you kind of have an idea of what is setting us back. You can see in here, there's a little bit of white. Well, that is filament that's got stuck past the extruder, and that is what's making this head not work properly. And so we need to get that out. We might have to dig a little bit deeper into this print head to actually get that out. It's not looking like it's going to come off easily. We might just need to remove this part here. So what we're doing here is we're just trying to remove this little arm, and then once I've got that arm out, I should have more access to pull that little piece of filament. See if I can get you a better shot. You can kind of see that filament more clearly now. The head has bowed out. Now, this was the piece that was in the extruder. All right, not to mention also, I think there's more. That is a mess. See all that little filament in here? All right, let's get that out. So that's very much problematic, and I'm not sure whether that's gonna write this head off. Well, I think this may fix it, hopefully. We'll go up the stairs and we will test it. Alrighty, we're back. We've cleared out a lot of junk from that extruder. So I'm going to reinstall the hot end here, and then hopefully this will get this back up and running, because what's the time now? Let's see, 6:38. So I'm hoping in the next 2 hours we can get some actual work done. We have our custom RV10. Now, all RV10s are technically custom if you want to get all pedantic on me, but this one specifically is very custom. Modified exhaust, throttle-fied cowl, oil cooler, air conditioning, and a bunch of other stuff. So we put a lot of work in this aircraft. And one of the problems that we have is that we've got this front-facing airflow. And now, there are a lot of different janky solutions on the market, and this is just another one of our own implemented janky solutions. And so what it is this airbox here. Now you'll notice this airbox is made out of glass fiber. Now I made this box myself by 3D printing molds and then doing layups and making it. And it's worked. We've done about 10 hours of test flight, and it seems to be functioning in every area except the last 97% of engine RPM. There we can see that it is slightly choking out the engine, which is probably due to some geometry issues, leakage. And so what we're gonna go do is make a few modifications to this. But making a new modifications to a glass fiber airbox is really problematic. Designing the molds, making the molds, completing the layups, doing the finishing, fitting, finalizing, all of that takes a ton of time. And it would be really nice if I could just 3D print an airbox for my aeroplane. And so that is the goal of this challenge for me tonight, is we're going to be looking at getting started on the design for an airbox that we can 3D print and fit in this hole. Now we are going to be replicating the design we have here, but I'm hoping to make a few changes. And we will go through those as we go. Anyway, you can kind of see this fits up into here. And so we will be going ahead and redesigning this part. So what do we need to do to get this redesign done? Well, we would like to continue to use this piece here, which is just the surface of the outer cowl. Now you can see we've got a window in here, which is for mounting it and fixing it to the actual throttle body. And so there are a few features that we need to consider. This was designed in CAD, so this entire system, let me wipe some goo off my hands. This entire system was designed in CAD. Now the airbox in CAD perfectly fit. In reality, we had a few issues due to the manufacturing of the cowl, due to the manufacturing of the airbox, and a few misalignments. However, we managed to make it fit. But we want to account for those errors because the whole point of 3D printing it is so that we can just plug and play. And so we need to make sure our tolerances are good, we need to make sure our fitment is right, and that the entire system can fit together in the space that we've got. That is really easily said and really hard to do. Many of the issues that we can face are print errors, print problems, complex geometries. Like there can be a lot of overhangs in parts like this. Temperature, for instance. This area, from what our testing shows, that we can get up to 140 degrees ambient without airflow. So that is once you've done your long flight, the engine is fully heat soaked, and you come in, you land, you switch the engine off, you're sitting at the fuel pump. This can get up to 130 degrees. Now, that temperature sounds like a bit crazy for a 3D print, but thankfully we have a really cool material that we want to try for it that supposedly can handle it. Well, we've got the physical products here that we know that fits. We have the CAD models that I will show you in a second. And so what we're going to do is we're going to actually 3D scan the cowl here. We're going to 3D scan this unit. We're able to then overlap all of that scan data to the point where we're within 0 deviation other than the scan tolerance, which is pretty tolerable with what I've got in 9-star. Then we will be importing all of this into the computer. We will be referencing the outside dimensions here. We'll be referencing this cowl itself, the surface, and we'll be able to design an airbox that perfectly matches up to each one of these surfaces. Now that sounds very complicated and we'll get through it slowly, but tonight, part 1 is we need to digitize these models here. We need to get the digital of that. We need to overlay all the data and export it into Rhino where we can get going. So I've explained the problem, I've explained the task, let's get into it. So it turns out I'm an idiot and forgot my scanner at home, so I'm gonna rush off there and I will be back and we will get this happening. Alrighty, so here we are. We've got the scan set up ready for you. So I've got this Ironstar from Shining 3D, great little infrared scanner. Very cool. I've made thousands of dollars off Facebook Marketplace with this thing, so it's earned its keep. We've obviously got the laptop, we've got the infrared dots, and what we're going to do is we're going to start compositing that scan. And the first thing we're going to actually do is scan the airbox here, and then we will move on to the aeroplane. A key part that I forgot to mention is this. This is my Jackery 500 watt hour power supply and no battery. What's great about this is it means I'm portable for about 4.5–5 hours of scanning, which is one way I can go on sites and do scanning with all of this system. But in this case, it means I don't have to drag cables all the way across the hangar. So very cool piece of equipment for this job. One of the cool features that this scanner has is that it actually takes pictures as well. Now, realistically, the pictures are pretty worthless for the actual reverse engineering process, but what they're really good with is kind of conceptualizing. Now, the human brain, if you would like, is terrible at interpreting a point cloud, is terrible at appointing an abstract series of lines. But what it's really good at doing is imagining and seeing colors and putting those colors together and connecting it. And so what I'll do is I'll show you later, but best thing to do before you do any scan that you want to reverse engineer on is, especially on this, calibrate your white balance. That way your images have nice colors, they're what you actually perceive, and as a result of that you're able to understand the system a bit easier than you would if you were just looking at a random point cloud. Alrighty, so we've set up the scan. You probably have seen a little bit of footage of that as we were going. We're doing a 0.5mm point cloud with texture scanning, markers and feature alignment. And hopefully then once we've composited it all together, we'll have quite accurate things. Because we're on a table, I'm going to set my working distance to about 0.5 meter. And because we're indoors, I don't need to be too bright. Now the application of the points here are very not important, but you do want to make sure that you have enough of them that you can actually generate some reasonable data. Also, the more you have, the easier it is for your scan to then get aligned, because the alignment software inside this actually uses features, but also very much uses the points to initially align the thing. So if you can figure out where all of these points are, they can just solve the problem quite quickly. And so we're just going to polka dot this place up a little. Now it is a bit oily from flight testing, and so we might have a little bit of sticking issues, but we'll just be able to wipe off and then hopefully get a stick from there. Now I'm putting these polka dots on the floor just so that it can track the table quite nicely as well, just because that will be a good reference surface. And you'll notice it's going to pick up the edges, which will make the feature tracking quite a bit easier. So data quality indicator on. We should probably make sure that this is not rocking in relation to the table. So it's perfectly still. Let's grab a block like this, and I might just put it on like there. Very cool. All right, let's get scanning. Alrighty. So there we have it. Scan 1 complete. So we'll notice, we can zoom around, we've got a pretty good top surface, pretty good side surfaces. We're lacking a bit of detail over here, so we might just resume the scan and get a bit more there. Get a good preview. Once it's aligned, we press play again, and I'll just rotate it down. Make sure it gets a bit of that detail. All right, now we're here. What we can do, what we don't care about data-wise, is anything below this point cloud here. So we can get our line nice done. We can delete that. We can then apply that to our scan. That basically just gets rid of this table because we don't actually care about that. We care about the object on top of it. So that data is irrelevant to us. Now, I do have a few questions about the IronStar software that I would love to ask the devs one day. I did meet the sales team at an expo I went to earlier this year, but they're always useless in terms of technical questions. Is why does rewinding take so long? It's one of those things in this software, like deleting is easier than rewinding, which doesn't make sense to me, but hey, here we are. All right, so now you've got your point cloud, you've got it green, it's looking all good. The object, you can kind of see how they line up here. What we need to do is generate our point cloud. Now, this might take a minute as well, but once we've generated the point cloud, that's processed, we are actually gonna go ahead and we're gonna scan this object again, but once we've flipped it, because we want to get the other side of the surface. So we've got a pretty good understanding of this lower surface here. But what we don't have a great understanding of is the top surface. Like we want to know the thickness, we want to kind of understand a bit of that as well. And so what we'll be able to do is we'll be able to align ourselves, if we do this right, if we think this through all the way, we'll basically be able to align this scan with the surfaces we can scan from under here with the top scan, the one we just did. And that will really set nicely and we should have good alignment. I do this. Right, so you can kind of see here that this part comes off. Now it's got a really ugly mounting feature here, which is just a bunch of flux and other stuff that I pushed in. I then aligned it all and I sealed it because I wasn't sure how it would fit. And you can see it's pretty ugly, but it was a very efficient method. So there we go. So now we're going to scan this airbox completely as well so that we can then align it with our scan, the bits that were hidden, just so we can understand this mounting surface a bit better. Cool, alrighty, so now we should be able to align our two scans. Now, let's see how they go. What we will do, I think, is we'll give it a chance, and then if not, we'll have to do a just quick manual align where we set 3 points and then the computer chews through that. But hopefully this will manage it all by itself. And in the meantime, I will prepare to polka dot. Oh, already done. Let's have a look. Let's inspect it. Now, I might just grab a mouse for this because can be slightly problematic reviewing data without an easy method to zoom around it. So, this looks pretty good. You can see here we've got a thickness. They didn't align those surfaces. There's clearly a thickness to it, which is very cool. Now, these surfaces seem to be lined up really well as well. That's cool. All right, so you can kind of see how it works. Now, if I exit here, and I just go to my project list, you can see by removing that project, we're missing this side of our point cloud. And so that's what we just want to get now, is we want to get a bit more of that data there, just so that it's a bit clearer of what's happening. Now the top surface is all fine, but yeah, we just want to make sure we fill that area in because it's hidden here and now we can access it. We might also get a scan of the inside of this lip in a second as well, because that will provide a lot of additional information. We might even be able to get this lip here when we 3D print it to perfectly fit in that hole. So there you go, a little bit of how I'm thinking. So let's add a new project, let's confirm it, and then we'll just scan the underside of this surface. Now, one of the interesting things I find with 3D scanning is that most of the time you're spent waiting around for processing, and now you may say get a bigger computer, but like this computer I can show you here, even now we're performance crunching and our CPU spiking, our memory's high, our GPU's barely hit. Like, this isn't necessarily an operatively intensive task, but it is very software limited at the end of the day. It's got to chew through data. It's just got to do a bunch of stuff. So it's not so much how much computing can you throw at it, because we've got as much computing as possible to throw at it, but rather how much patience do you have to let it do its job, which is annoying, but also a reality. We're talking about, 500,000 points here. We're going to be 3D scanning in here. Now, one thing to note is it's already polka dotted up because we've been doing a bunch of other reverse engineering at the moment. But we're going to get in here, we're going to scan that engine, and then the magic that will happen is we'll be able to have the engine, the airbox, and we're actually able to see into a hidden 3D space. Now this is where it's really cool, because right now if I put this in, the airbox in there, we can't actually see anything. There's no way of understanding the tolerances, the deviate, all of that sort of thing. But with this, we're able to overlay and understand the situation far more in-depthly than I would have expected. So let's get straight to it. Now it's really important that we get a good scan not only of the engine here, but obviously the cowl surface, because that is the basis that we will be aligning off. So we don't want to skimp out on anything. We want everything to get green before we move on. Now let's make sure this is on the right setting. New project, confirm. Now we're going to scan all of this again, and hopefully we can line up all our data. And so we're here. We now have our scans done. We've got them, we've got all the scans I think we need. If we need any more, we can come back and get them. We've processed them, we've aligned them, and now what's left is we need to import it into the computer and we need to analyze it. Once we've done the analysis, that will conclude this part of the series on the 3D printed airbox, and we will move on to design tomorrow, hopefully. Possibly the Saturday. Alrighty, let's pack up.